the topic which we are now going to see is the momentum of electromagnetic wave equation. That is the thing, we are going to find the formula for finding a momentum of electromagnetic waves. So Maxwell predicted that electromagnetic waves carry energy when it is traveling from one part to another part. And also, if the electromagnetic wave is carrying energy, it also carries the momentum even when there is no mass associated with it. But here we are taking into account the effective mass for finding a momentum. So what is meant by an effective mass? Effective when then wave particle is traveling from one part to another part, when it is traveling, the mass of the electron will vary with respect to the movement. That is called a effective mass. So the effective mass of an momentum of an electromagnetic wave is found using a energy and also a Poynting vector. Now we are going to see the topic, that is momentum in terms of energy. So we all know the formula E is equal to mc square, Einstein's relation. That is, similarly the energy U with the effective mass of an electromagnetic radiation can be written as, instead of U we can write it as what? mc square. U is equal to mc square. Then what is M? M is equal to U by c square. U is equal to U is equal to mc square, that is, instead of M, E we have taken U. And M is equal to U by c square. And we know that momentum of the particle with mass m and velocity v, it can be written as what? P is equal to mv. Similarly, substitute this U is equal to mc, that is, M is equal to U by c square in the equation 3, that is P is equal to mv. Instead of m we are substituting that value. So when you substitute that, momentum is P is equal to U by c square into V. This is the formula for momentum. If the electromagnetic wave which is traveling along an z axis with velocity c can be represented as Ck. It can be represented as what? Ck. So the above equation becomes that velocity v is equal becomes Ck. So the above fourth equation, instead of v we are substituting Ck. So P is equal to U by c square into Ck. This c and c will get cancelled. When these two c's are getting cancelled, P is equal to Uk by c. So therefore the magnitude of momentum, this is the vector. So the magnitude of the momentum P is equal to U by c is the formula for momentum of electromagnetic waves in terms of energy U. Now we are going to see momentum in terms of Poynting vector. That is, we know the Poynting vector S vector is equal to E cross H is equal to UCK. So here S vector is equal to UCK we can write. We can take that. That is, then UK is equal to what? S by C. Substituting the equation 8 in equation 6, that is P is equal to UK by C. In this formula, what happens? P is equal to 1 by C into S by C. So this equation becomes P vector is equal to S vector by C square. What is the value of C square? C square is equal to 1 by epsilon naught mu naught. So when we substitute this in the above equation, P vector is equal to S vector by 1 by epsilon naught mu naught. This 1 by epsilon naught mu naught will go to the numerator by multiplication. That is 1 by the term, no? So it will go to the numerator. So P vector is equal to epsilon naught into epsilon naught mu naught into S vector. So this becomes, what is the S vector value? It is E cross H. So momentum P is equal to epsilon naught mu naught into E vector cross H vector is the formula which represents the momentum per unit volume of an electromagnetic wave in terms of Poynting vector. Thank you.